Hello everyone, welcome back to the channel. I am Kalaivani, Assistant Professor from SNS College of Pharmacy and Health Sciences. So in today's lecture, we are going to understand one of the most essential and analytical techniques used in pharmaceutical sciences and other than that in biotechnology and research laboratories, and that is high-performance liquid chromatography, commonly called HPLC. In this session, I will explain the principal components working and the role of the UV-Vis detector with the help of a simple animation-based explanation. So without any delay, let's get started. So first, what is HPLC? Well, let us begin with the basic data. HPLC is a high-resolution liquid chromatography technique where the mobile phase is liquid and moves through a column under high pressure. We use HPLC to separate, identify and quantify the components present in a mixture. Unlike traditional column chromatography, here we apply high pressure using pumps to push the liquid mobile phase through a tightly packed column, giving very sharp and accurate results. Components of the HPLC. Now moving on to the components of an HPLC system. You will see these major parts in every HPLC setup. The one, reservoir or solvent system. This holds the mobile phase. It may be water, methanol, acetonitrile or a mixture. Pump. Next we have the pump which applies high pressure, usually between 1000 to 4000 psi to deliver the mobile phase at a constant flow. Then comes the injector where we introduce the sample, and this may be a manual injector or an auto sampler. Column. Now the heart of the system. The HPLC column usually packed with silica based stationary phase. The separation actually takes place here. Detector. UV, VIS. The separated components finally reach the UV VIS detector where detection and quantification happen. Computer or data system. Finally, the signal is displayed on a chromatogram as a peaks on a computer system. So, let us now discuss the principle in simple words. Different compounds in the sample have different affinities towards the stationary phase inside the column. Some components get strongly retained and some get weakly retained. Due to this difference, each compound travels at a different speed causing different retention times. This is how separation occurs in HPLC. Now let us understand the working in a simple step-by-step manner. Injection. The sample solution is injected to the following mobile phase, and this is step 1. Coming to step 2, passage through the column. The mobile phase carries the sample through the column. Inside the column, each molecule interacts differently with the stationary phase. And step 3, separation based on retention time. Because of variable interactions, each component moves at a different rate and gets separated as individual bands. Step 4, detection. When these compounds exit the column, they enter the UV-Vis detector. And step 5 is chromatogram formation. The detector converts the signal into peaks. Each peak corresponds to a compound and the time of the peak is equal to retention time. And this is how we identify and quantify each component. So let us now move to the major part of today's video, that is the UV-Vis detector. This works on a simple principle. Many organic compounds absorb ultraviolet or visible light. When a separated compound passes through the flow cell, the light intensity decreases due to absorption. This difference is measured by a photodiode. The detector converts the change in absorbance into an electrical signal, and this appears as a peak on the chromatogram. Greater the absorbance, higher the peak, meaning more concentration of the compound. Most compounds absorb at 254 nanometer, which is why many HPLC systems use UV lamps at this wavelength. So I hope that you all understand the procedure. And now coming to the applications of the HPLC. HPLC is widely used in pharmaceutical drug analysis, quality control and purity testing, identification of unknown compounds, quantification of active ingredients, food and beverage testing, detection of impurities, herbal and phytoconstituent analysis. This makes HPLC one of the most important analytical techniques in modern laboratories. So to summarize today's lecture, HPLC is a liquid chromatography technique operated under high pressure. It contains a pump, ejector, column detector and a data system. Separation is based on the difference in retention times. The UV-Vis detector measures absorbance and produce peaks that help identify and quantify compounds. With this, we have come to the end of our lecture on HPLC with the UV-Vis detector. Thank you for watching, and if you found this helpful, feel free to subscribe and support the channel. Thank you so much.